Hello everyone and welcome to this factoring polynomials video. The topic today will be difference of squares. The difference of squares method only happens when there's two terms. So if you have two terms in your polynomial, we might be able to factor it using difference of squares. The key to this is, can you rewrite the polynomial in this form? If you can rewrite the polynomial in this form, then it is a difference of squares. And if it's a difference of squares, it has a really easy pattern to factor with. Okay, so what times itself would give you a squared? Well, a times itself gives you a squared. And what times itself gives you 16? 4 times itself gives you 16. This step here gives the difference of squares method its name. You can see difference, that's subtraction, and these are both perfect squares. So when you have two terms and they're both perfect squares separated by a subtraction, you have this difference of squares. Now you can think about all that, or you can just put it in this little pattern here, this squared, something squared minus something squared form. And if you write it in that form, then you know it's a difference of squares. Okay, so now how to proceed from here? I'll switch back to black. From here, you get two binomial answers, and you simply put what's in your brackets into your final answers. Now, the key, though, is that we use opposite signs. So I'm going to have a minus 4 and a plus 4. Now, why would I have that? I'll leave this as blue. Well, if we check this out, remember we can always check our answers by multiplying. Okay, a times a is a squared. A times positive 4 is positive 4a. This is negative 4a. Negative 16. Gather my like terms. A squared. 4a minus 4a is nothing. It cancels out. You get negative 16. That matches what we had in the beginning. If I would have had a plus 4 and a plus 4, I'll do that as well. So if my signs would have matched, you'll see I get something slightly different. A times a is a squared. This will be positive 4a, positive 4a, positive 16. And when I go to gather my like terms, I get a squared plus 8a plus 16. So I get this middle term. So the opposite signs, the negative and the plus, they will cancel out your middle term. If I had a minus 4 and a minus 4, I'd get the exact same trinomial as I got down here. This middle term would be negative 8a. So again, we wouldn't want that. So to make that middle sign disappear, we have opposite signs in our answer. Okay, let's look at another example. So d squared minus 49. Okay, so I see there's two terms. I know, well, I might as well try difference of squares. To determine if it is a difference of squares, because not everything's a difference of squares, you have to have two perfect squares. So if one's a perfect square and one isn't, then we're stuck. We can't use difference of squares. Anyway, back to this question. I'm going to put this little form in. I'm going to see if I can rewrite the polynomial. And if I can, then it is a difference of squares, and I use my super easy pattern. If I can't, then it is not, and I have to either consider a different method, or maybe it's just a prime polynomial. Okay, so what times itself equals d squared? Well, d times d. What times itself will equal 49? Well, 7 times 7. So then I get d minus 7 and d plus 7. Or if you wanted, you could have wrote d plus 7 and then d minus 7. So as long as the signs are opposite, that's all that matters. The order doesn't matter. Let's check out C. So now I have two variables here. Again, as soon as I see there's two terms, I'm going to say, well, I might as well try difference of squares. I want to get my middle term here. My middle step. Once you get good at this, and once you can identify if something is a difference of squares without writing it out, then quit writing out the middle step. But until then, it's quick to do, so why not? So what times itself equals x squared? Well, x would. What times itself equals y squared? Y times y would. Then x minus y, x plus y. Pretty easy. Check out D. D squared plus 4. Okay, two terms. What times itself equals D squared? Well, D. And what times itself equals 4? 2. But do you see any other issue with this? Hopefully, you noticed right off the bat there was a plus. It needs to have a subtraction. And if it doesn't have a subtraction, then it is not a difference of squares. This one is actually called a sum of squares, but that's just a name. We're not going to do anything with it. This ends up being prime. So this here, we wouldn't do anything with it. This would actually be your answer. There's nothing we can do to it. It's like finding the prime factors of 7. Well, 7's already a prime number, so we're just stuck with 7. All right, move on. Okay, again, this one looks kind of funny. Now you might be looking, okay, let's check that negative sign out. And you'll be looking and you'll say, oh, we have a plus sign here. Therefore, it's not a difference of squares. Well, this case, or something to always remember, it's can you rewrite it so that there's a subtraction in the middle? And in this case, we can. You cannot always. But if I rearrange my terms, I see there it's x squared minus 64. Maybe you've identified that is a difference of squares. Maybe you haven't. But if you haven't, we'd go to our middle step. That'd be x. What times itself equals 64? That'd be 8. So there's my proof it's a difference of squares. Go to my answer. X minus 8, x plus 8. Great. F. Check it out. Two terms. There's a subtraction, so this should be a nice easy one. What times itself equals a squared? A does. What times itself equals 15? Yeah, I don't know either. Nothing, right? There's going to be a run on decimal. So in this case, again, we can't use difference of squares. We try a different method. There won't be anything that works here either, so we'd consider this one prime. But I don't want to confuse you. This would be your final answer. You just wouldn't do anything. Okay, let's progress a little bit. Remember your good habit. By the way, I have a cough, so I'm sorry. There might be some starts and stops to this video because I'm coughing. Okay, our good habit in factoring is to take out a GCF. So we need to examine every polynomial first. Okay, is there a GCF? 5 and 45? Yes, there is. It's a 5. Remove the 5. Rewrite what's left over. And you can see, because we always try to factor the remaining polynomial, you can see here this is a perfect candidate for difference of squares, and I can see, yep, that would be a difference of squares. So I can go right to my answer without showing that middle step, just in case you're not using it either. I'd go A and A, I'd go 3 and 3, and then negative and plus. B, same thing. Let's check for a greatest common factor. And if you look, hopefully you noticed, well, 3v would be a common factor. And that would leave you with then v squared minus 12 divided by 3 is 4. V divided by itself is just 1. So 4 times 1, which is just 1. And once again, we now look at that. That's a difference of squares. If you're not sure why, do the middle step. But I get 3v, v minus 2, v plus 2. Again, greatest common factor, you want to pull it out at the start so it makes the future factoring easy, and in both of these examples, it's done that. C. Okay, so there's two terms. I see some squares, but like it's kind of big numbers, so I just want to double check it. So I'm going to use my middle step because there's not a lot of work in this middle step, and it does all my thinking for me. So 64x squared, that might be a big number to think about, like what times itself would equal 64x squared. So break it up, like what times itself equals 64? 8. What times itself equals x squared? X. So then 8x times 8x would give you 64x squared. Same with the 81y squared. I'm going to break it up. What times itself equals 81? 9. What times itself equals y squared? Y. And there we go. I've got my middle step. So then I can go right to my answer. 8x minus 9y, 8x plus 9y. And another good factoring technique, or good habit to be in, is double check your final answers to make sure you can't go any further. And there are no greatest common factors left in those factors, so that's good. And neither of them are differences of squares, because sometimes another difference of squares can pop up there too. But we're good. So in summary, we'll look at a couple things here. First of all, the pattern. There's a pattern. It's kind of, I use symbols for it, but it's nice and easy. If that doesn't quite make sense, make sure you come find your teacher or myself. And when to use this? Well, when you have two terms, when both are perfect squares, that's when to use it. But really, you don't have to think about that. You can go right to this. Just, does it fit in this form? Because if it fits in that form, it does have two terms, and they are perfect squares. All right, I hope that helped everybody. If it didn't, again, come find me. See ya.